My name's Colin Bailey. I'm a mathematics teacher at Merewether High School. I've been teaching and preparing students for Maths HSC since the late 1980s. I've been a HSC marker in mathematics. I've done that for 4 years, and for the last 3 years I've been a senior marker on the mathematics course. Let's just have a quick look at the structure of the HSC exam. Your exam is going to be about a 3-hour examination. Section 1 contains 10 multiple choice questions. Now, in 2012 they changed the HSC paper over. Before it used to have 10 questions, now it has 10 multiple choice questions at the start. The multiple choice questions, although they're worth 1 mark each, you've got to be careful when you are doing them. They're not always as easy as what they seem. In 2015, they put up a question using the trapezoidal rule for 4 subintervals. The sort of question that really would take 2-3 marks if it come up later in the paper. For this, we needed to calculate the height, we needed to determine our subinterval boundaries, we needed to work out the y values or the function values, and then we needed to substitute into the correct formula. Now there's 4 things there that we wanted students to do, all for 1 mark. Now, for 1 mark in the paper, you're looking at about 1.5 minutes per mark. But that question there is probably going to take you about 3 minutes to do. So when you're doing your multiple choice, you've got to be very careful because you can get bogged down and take too long. Section 2 of the paper contains 6 questions. Each question is worth about 15 marks, and each question consists of short answer parts. And I'll talk about them a bit later. Your HSC paper is broken up into sections, into topic areas. And if you can see the table there, you can see I've mapped out over the years roughly how many marks are there for each question, from basic arithmetic and algebra down to plane geometry, probability. Notice on the right hand side for 2015 the big ticket items, and the items that when you plan your study that you really want to think about are series and applications, geometric applications, differentiation, and applications of calculus to the physical world. They were the big ticket items from 2015, and they've basically been the big ticket items for the last 5 or 6 years. If you have a look at the courses though, the preliminary course, and I've got 3 sections there highlighted: plane geometry and applications of plane geometry. There are topics in the mathematics course that come from both the preliminary section and the HSC course, plane geometry being an example of one. Linear functions and line being a second example with coordinate methods of geometry. Trig ratios and trig functions. I highlight these 3 because these 3 are topics that have both a preliminary application and a HSC application. Your actual exam is mainly based on the HSC course. Where the preliminary course, well, it's basically assumed knowledge. Right? We think that you know everything from your preliminary course. But the questions that focus on the HSC course, they can relate to knowledge, skills or understanding from the preliminary course, things that you are expected to know. When we do presentations, students normally come and say, well, what makes a preliminary question and what makes a HSC question? Now, for example, in 2015, question 12A, the question was, find the solutions to 2 sine theta equals 1. Now that's a fairly generic preliminary course question. But what they did is they added on for theta lies between 0 and 2 pi. Now once you've added the 2 pi in there, all of a sudden you're dealing in radians, all of a sudden it's a HSC question, and it does not become part of the preliminary coursework. In 2013, question 12B, there was a nice generic coordinate geometry question, and they had to show an equation of a line and a perpendicular distance and a length. But part 4 then went on and said, well, hang on a minute, find the area of the trapezium. Now, finding the area of the trapezium, that took the question from a preliminary course question to a HSC course question, and it didn't take that part, it takes all parts of it. So when you're at school and you read something like only 20% of your course 20% of your HSC mark should be based on the preliminary course. Although that is true, it is very easy for your teacher, for the examiners of the HSC to tweak the questions a little bit and make them HSC questions by just including one little part from a HSC course, especially in trigonometry, plane geometry, or coordinate geometry. It's very easy to do. So you're preparing for your HSC. Can I please suggest that you go back to the Board of Studies site and go back through and have a look through all the HSC exam papers they've got there. On the HSC site, they go back to 1995. And if you have a look through it, you'll see they've got the examination paper and they have notes from the marking centre. Go and look through the notes of the marking centre. That's where the senior markers from each question will talk about things that the students did well, things the students did poorly, some tips for next year's. From 2012 onwards, they also started to include some solutions or mathematics marking guidelines to give you a little bit more of a guide of exactly how much working was required to achieve full marks for each of the questions in the course. Also go back, look at trials and mid-course papers from other schools. Our current HSC course, I think, first was sat in about 1983. In the late 90s, they then reordered the topics into the preliminary and the HSC courses. And then in 2012, they introduced the multiple choice questions. But basically, you can go back to the early 80s, which means there's 30 years worth of HSC papers, 30 years worth of trial papers, mid-course papers for you to look through, because you really want to do as many questions as you can. Textbooks and study guides are another source. I imagine your school is either using the Cambridge 2-Unit Mathematics textbook, or the Maths in Focus by Margaret Grove, or the new Senior Mathematics 2nd edition. They're probably the three most popular ones. Whichever one your school is using, go out and source one of the other ones. They are another great source of questions for you to use as part of your study routine. Excel, Pascal Press study guides, they're there as well. They are great sources of questions. As part of your study, you want to go back and do as many different questions. The idea is that you want to get into the exam and you don't want to be surprised. You want to look at a question and say, I remember I did that question, that's from the 2012, 2009, 1994 paper, or similar to it. So you do as many different questions. The big change for 2016 is that the Board of Studies has released what is called a reference sheet for the Mathematics course, the Extension 1 course and the Extension 2 course. Previous to 2016, your teachers would have been saying, you've got to learn your formulas, you've got to learn your formulas, and there is something like 30, 40, 50, 60 formulas out there for what people needed to learn for their HSC. In 2016, it's a little bit different. In this reference sheet, some of the formulas that you're going to need are given to you. Things like sum and difference of two cubes, differentiating by first principles, compound interest formula. But what I think is interesting is what's not included. Now, a formula that is a case of or is readily obtained from another included formula is not included. Now, if you've listened to me say that and you think, what on earth do you mean by that? On the formula reference sheet, you are given sine squared theta plus cos squared theta equals 1. But you are not told tan squared plus 1 equals sec squared, and you are not told 1 plus cot squared equals cosec squared. So you need to look at the reference sheet and make notes, make a list of the formulas that you are expected to derive from the formulas that are given. So when you go into the exam, maybe you can make a quick note of them before you commence. The other things that are not included is a formula that essentially represents a statement or expression of a fundamental serious concept or definition. Okay, big words. Basically it means if the syllabus says something like they want you to find the midpoint of an interval, then they're not going to give you the formula for a midpoint because they expect you to work that out from the statement from the syllabus. So once again, make a note of those sorts of formulas, things you need to know. It's a help, it's not a be-all and end-all. The last page, of course, is extension 1. So if you're a 2-unit student in the 2-unit exam, you only need the middle 2 pages open in front of you. Okay, as a senior marker, what am I looking for? What am I looking for? Markers look to give away marks. They don't penalise people, they award people. I don't like these people when they say, oh, I dock you a mark for this or that. So never give a blank answer. Always make sure you write some sort of an answer for every single question. If the question is worth more than 1 mark, then you're going to need to show some working. Markers will rarely give more than 1 mark for a bald answer. Usually it is only 1 mark for a bald answer. Every other mark is going to be there for working, and you're going to need to show your working. And you've got the marks there so you can use them as a guide as you go along. Read each question carefully before writing your answer. Highlight any key words. Now in the 2015 paper in question 13A, the question said by finding the exact value of sine A determine the exact value of the area of triangle ABC. And I highlighted the words exact there, right? Because there are a number of students, when they were doing it, they did not find the exact value of sine A. They had some sort of decimal equivalent. They did not find the exact value of the area of triangle ABC. They just used their decimal equivalent. So if the examiner has used some keywords in the question, the markers are then expecting you to follow those instructions. So take a highlighter pen with you. Highlight those keywords. Maybe things like how they want the answer written or any of the other keywords. Make sure you show your substitution into formulas. Basically, we mark on the substitution line. We do not mark on the final answer. We mark on the substitution line. Now in 2014, they gave a question for the roots of the quadratic equation 2x squared plus 8x plus k equals 0. The roots are alpha and beta. Find the value of alpha and beta. Write it as negative 8 over 2 because that's the substitution step. Don't write it as negative 4. As a HSC marker, we see negative 8 over 2. We just go tick, yep, they've earned that mark and move on. We don't even look at the negative 4. But we want to see the substitution. We want you to show us that you know what you are doing. We now have question booklets. They're A3 double-sided, so you've got at least 3 A4 pages on each booklet to show it. When you're doing diagrams, make your diagram at least half a page. I know some people have said a third of a page, half a page. The bigger, the better. The bigger it is, the easier it is for the marker to read the information on it. The easier for you to show your information. You're not trying to cram it up into a small space, right? And you've got the page there, so use the page. Copy any diagram you're given as part of a question, especially in geometry, and I'll talk about that a bit more later. Use a ruler on your diagram. Use a ruler for your x and y axis. Use a ruler for your geometric diagrams. Don't divide your page into 2 or more columns. It's hard for the marker to see where you are going sometimes. Have they gone to a new page? Have they just gone to the top? Leave a space between each part, especially early on. You're not going to use the 3 pages early on, so leave a space between each part and highlight your answer. All you're doing there is making it easier for the marker to identify where your answer is. And don't pre-label your page. I've seen students who do question 11 and go A, B, C, D, E, F, G, and then all of a sudden realise, oh, hang on, I need more space here, so they've got to cross them out and change them. So don't pre-label your page. Don't use liquid paper. Liquid paper, hopefully your teachers have already told you, it's a no, don't do it at all. And if you don't like your answer, cross it out with a single line. There was a bit of discussion in 2015 about whether markers would go back and look at previous attempts. And at the end of the day, the decision was to stay with what we do in mathematics, which was if your final answer is not worth full marks, then the markers will go back and look at any previous attempts to see if they are worth any marks. whether they're crossed out or not. Now, if you go and scribble your answer out, we can't see it. So we can't give you marks for it. So just a single line through it. You're giving us the chance to give you marks. Write in pen. Don't write in pencil unless you're doing it on a diagram. We don't get to see your original script. All we get to see is a scan of your answer booklet. And we're looking at it on a screen. And if you write in pencil, it can be so hard sometimes to read your handwriting, read the diagrams. So please, please write in pen. I think the paper actually says blue or black pen, but write in pen. It does make it easier to read. I talked earlier about giving your answer in an exact form. Normally early in the paper, either in question 11 or in one of the early multiple choice, there'll be a question there that tests rounding, whether it's to decimal places, whether it's to significant figures. But that's where they will test rounding, and they only test it in that place. Once you've got through that rounding question, they do not check it later on, because we can't go backwards and forwards between our markers to see whether you have been not awarded the mark for rounding or not, so they do it in one place. But write down your calculator display first. If it's worth 2 marks and you write down the wrong display because you've pressed the wrong button, you can still get 1 mark for showing that you know how to round, especially to significant figures, which is the hard part. Once you've been tested on that, rounding is then ignored everywhere else in the marking process. We pay the marks at the calculation step or the substitution step. I think I mentioned earlier, make your diagrams at least half a page. Please make them at least half a page. In the geometry section, it normally says copy or trace the diagram first. If you want to trace it, that's fine. I prefer to draw it because you can make it even bigger. One of the big criticisms from the HSC markers is that students do not copy their diagram and then they go and add points or lines to their diagram. The diagram on the paper. Now we don't get to see the question sheet. So you might have a figure where you have added a point K, you've added a line X, Y to make it easier for your explanation. But if you don't draw the diagram and you don't show us the diagram and show us where these points are, we don't know what you're talking about, and it makes it very hard to award you the marks for that section. If you've got multiple triangles, don't be afraid to use colour to highlight the different triangles you're using. Or don't even be afraid to pull the diagram apart into separate triangles, especially if you are getting a similar triangles question or if you're getting a congruent triangles question. Anything you can do to make it easier for the marker to know exactly what you're doing, where you're heading, where you're getting the information from, makes it easier for them to award you the marks. You make it easy for them, they can make it better for you. So you've walked into your HSC exam and you've sat down and the examiners, the organisers, the people running it have said, right, 5 minutes reading time. It's my recommendation, don't read all the paper. Don't look at the last question. Go and look at question 11 and look at question 12 and read them carefully. Skim read the rest. I've known a lot of students who have started to read the paper. They get to question 16, the last question, and all of a sudden they think, oh my goodness, how on earth do I do that? And they get into a bit of a fluster and they lose their train of thought, and it throws them off completely. So just read 11 and 12. Once you've read them, once you've had a quick skim, go back to 11 and then start to plan your answers. And in that 5 minutes, you can basically have the answers, at least for question 11, worked out in your head, possibly even some of question 12. So when the person says, okay, you can commence writing, you open up your question 11 booklet, put part A, and you can go straight away. Now question 11 should be very straightforward. I tell my class, they should be aiming at an average of 14. 14 is their pass mark out of 15. Hopefully they get 15. But it's very straightforward. So you want to commence the paper on things that you know what you can do. You can get into the paper. You can then feel confident. You can think, gee, things are going well here. I've recognised all these questions. Right? Question 12 should be fairly easy as well, fairly straightforward, sorry. You're aiming 12, 13 out of 15. Once again, you're doing things that you know you do. These are straightforward questions. These are questions you have practiced, that you're prepared for. And then you're into the paper, things are going well, your mind's in a good space for mathematics. Then you can choose, do I go back to the multiple choice or do I go on with question 13? It's up to you. But you want to start and have your head in a good spot. What sort of terms do they use in the HSC exam? They use the word hence, or they use the word hence or otherwise as another key term. If you see the word hence, that's the examiner saying, look guys, what you've just worked out, you've got to use that in the next section. You've got to use it. That is the best way to do it. Hence or otherwise gives you a few options. It's still the best way to do it, and I would always recommend, if whatever you've done in part 1, if you've got a hence or otherwise in part 2, use what you've worked out in part 1. That's why they've set it up that way. They want you to use that to work it through. But if you can think of another way, not necessarily a better way, but if you can think of a better way, then you can go and use it. The word explain has started to come into some of the maths HSCs. Now, explain means you need to show cause and effect. In terms of mathematics, that means how does the result of some calculations or substitutions that you have done previously prove some sort of a certain concept? Now, from other subjects, you should be used to what explain means, but in mathematics, it's a bit new. In 2011, I marked question 7, and the question was the velocity of a particle moving along the x-axis given by velocity equals 8 minus 8 e to the minus 2t. Part 1 was to show the particle initially at rest, which meant sub naught in for t and show the answer was 0. Part 2, show that the acceleration of the particle is always positive, i.e. differentiate to get an expression for the acceleration, and then explain why a positive number divided by a positive number is always positive. But part 3 was then they put the word explain. Explain why the particle is moving in a positive direction. And all they needed to do was then go back and reference the 2 results that they had previously found, i.e., if it starts at rest and it has a positive acceleration, then it has to be moving in a positive direction for t is greater than 0. And all we wanted you to do was to take the 2 results from above and then link them into the explain. So go looking for that sort of thing, and we want an answer in words, we don't want an answer in numbers, but it is becoming more popular. Show. Show, you're probably going to get 5, 6, 8 shows throughout the paper. You are given the result, and the result you're given needs to be the last line in your working. Now, there is no marks given for that result. All the marks come earlier. The idea being that you've got to show enough working to convince the marker that you would have got to the result even if they hadn't given it to you. Now, if you're going to convince the marker, include more lines than you normally would. Show your substitution. Maybe rather than jumping from the substitution straight to the numeric answer calculation, add an extra line working in there. You're trying to convince them. They basically put their hand over your answer, over the part they want to show, and then they look at everything that's before that and then say, right, from everything before that, does that lead to it? Now, there are occasions when people get lost in the algebra and they can't show it. And they get to the end and think, I'm supposed to show this result and I can't get to it. That's fine. You haven't earned the marks for that part, but the examiners have set the question up so that you can take that result and use it somewhere else. You would be expected to use that somewhere else. I think in the 2014 HSC there was a max-min question. Part A show, Part B show, Part C. And once again, A led to B, sorry, Part 1 led to Part 2 led to Part 3. But if you couldn't do parts 1 and 2, you could still do part 3 and earn the marks. And that's where having the show that's gave candidates that option. I wanted to talk about 2 other terms very quickly, and they're very simple terms. One was simplify. Question 11, Part A, 2015, was simplifying expression, and I was surprised that basically not everyone got it right. Simplify means expand brackets and or collect like terms, right? Very simple. Part B was factorise. Now we know how to factorise, so you look for common factor. Then if you've got 2 terms, look for difference of 2 squares or sum of difference of 2 cubes. If you've got 3 terms, it's a trinomial. If you've got 4 terms, it's by grouping. But when you're asked to factorise, you expect to write your expression as a product of 2 or more expressions involving brackets. Now in 2015, question 11b, they used the word Philly to assist candidates. Why am I saying this in this little presentation here? We were surprised how many students went on to solve it. And factorise has not been solved, simplified has not been solved. I don't know, for some reason, but solve means solve. So we did not want answers of x equals plus or minus 3 or anything like that. So know your terms, know your words, know your instructions, know what they mean. What strategies do examiners use to make the questions more challenging? They normally do them by a few ways. They can put in some harder values. Now if you're looking at these 3 questions up there, I don't know how many people recognise that actually the first one there, the solve using exponentials, is actually a quadratic equation. And you've got to arrive at a quadratic equation, except it doesn't look like a quadratic equation, it looks like an exponential equation. So they've made that harder by rather than using x, using e to the x. Maybe they will change the domain for x values for a trig equation. You've probably done hundreds of them between 0 and 2 pi or 0 and pi. How many have you done between negative pi and positive pi? Or how many, in terms of logs, how many log equations have you done? Right? They will ask you questions and they will throw in little things to make them a little bit harder. Maybe they'll include more than one topic area. This was an area under a curve that involved y equals ln x. And if you're looking at that and you're thinking, oh, area under a curve, hang on, that's an integration question. And then you think, hang on, I can't integrate ln x. What am I going to do here? It's an example of a question that's just a little bit harder by throwing in a different type of trig graph. Obviously, you'll have to do it about the y-axis rather than about the x-axis, and then subtract the y-axis area from the rectangle to get it. But they will make things a little bit difficult by combining different areas. Sometimes they'll ask a question in a non-standard context. They've done 2 great trig graph questions. The first one was in 2009. It was question 7b. And it was where the boat comes into the harbour. And then we had the tides followed a sine curve. Now, great question, but all you're really doing was just graphing a sine curve. You're finding some key values and then working it through. But it was asked differently. It wasn't just graph y equals sine x or y equals sine 2x, etc. In 2013, we had another one where it was a population of a herd of wild horses. Basically, this is just a cos curve question. You're asked to sketch it, but it's just a cos question. But it was asked in a different context. So, what's going to be in your HSC exam? Especially in question 11, I think you're going to get 2 of a product rule, a quotient rule, and a function of function rule. And those 2 are going to involve either a log to x, an e to the x, or a trig function. Now I know you're going to get them, or something. So there's no excuse for not knowing any of the formulas, any of the rules to go through. In 2015, there was an exponential as part of a function of function, and there was a log as part of a product rule. In 2012, they threw in cos x on x squared, so they had a trig function as part of a quotient rule. We know they're going to be there. There is going to be probably one definite indefinite integral in question 11. and it's going to be either a log, an exponential or a trig. Now these are the questions that you are aiming to get fully right. You want 14 out of 15 on these. We know they're coming. We know they're coming. So there should be no excuse for people being surprised about, oh, I didn't expect to get such and such. In 2015, it was the integral of y equals cos x as a definite integral. There was integral of x on x squared minus 3. It was a log question. 2012 was something very similar. 2014 was integrate a log and an exponential. We know they're going to be there. So make sure that you are confident at doing, they're only straightforward ones, there's no big tricks there, but you're confident in doing it. After the straight differentiation and the straight integration, the third question I know you're going to get is a curve sketching question. They come up almost every year. They are very straightforward, they are very predictable in what they want you to do, and they're the sort of question again that you should read, oh yes, I know what I'm supposed to do here. Question 13 of 2015 was an example of a curve sketching question. And part 1 said, find the stationary points and determine their nature. Now, you read those words and you've got to think, right, I know exactly what I am doing here. I know I'm supposed to find first derivative. I know I'm supposed to find second derivative. I know I am supposed to make first derivative equal to 0 and solve it. I know I'm supposed to find the corresponding y value. I know I'm supposed to test by subbing either into the second derivative or into a table with the first derivative showing that the gradient changes from negative to positive or positive to negative if it's a max or a minimum stationary point. But they should be, it's a default action, you should just do it almost without thinking. Part 2, given that point lies on the curve, prove it's a point of inflection. Straightforward. Right, point of inflection, second derivative equals 0, and then I want to show that there is a change of concavity either side. Part 3, sketch the curve, labelling the stationary points and the points of inflection and the y-intercept. Please notice that this question asked for 3 things. Now if it asked for 3 things, we are looking for 3 things. Right? We are looking for the stationary points on the curve, we are looking for the point of inflection. So my solution up there went through and found first derivative, found second derivative, and did all those things as we worked through. When you're determining nature, I know some people like to use second derivative tests, some like to use first derivative test. I'm not going to tell you which is the best, which one to use, because I think it depends on the situation. Sometimes if it's easy to find second derivative, that's what I will use. But you need to show the substitution into the test, and you need to show what you are substituting into. You cannot just write down a series of numbers that are added together. If you are dealing with the first derivative test, you've got to write dy dx or y dash. If you're dealing with a second derivative test, you've got to show y double dash equals and show the substitution. After you have shown the substitution, you should then have some sort of a conclusion. I always liked with my second derivative test to do a reference back to either less than 0 or greater than 0 before you then write your conclusion as a maximum stationary point. For that question there, I've got an answer of y equals 88 on 27 when x equals negative 1 on 3. My second derivative worked out to be negative 4, which was less than 0, so I knew it was a maximum stationary point. If I was using the table, notice on the side of the table I've got my x and my y dash. It's easy for the marker to see, oh, they're substituting into the first derivative. And I am showing the substitution. I'm not actually working it out, but I'm showing the substitution and then I am showing a reference back to 0. And hence I'm then showing this is a minimum stationary point. We are looking for the substitution. We want to know what you are substituting in for. For point of inflection, the biggest downfall for students is they do not show there is a change of concavity. They solve it, but they don't show there was a change of concavity. Now this question in 2015, you were told there was a point of inflection at x equals a third. Now it's okay to use values either side. Now if you've used those values as part of your testing process for stationary points, that's fine. You don't need to do a great, I just rewrite out the simple test, show that one is less than 0, show one is greater than 0, just show it's a point of inflection. But you need to show the change of concavity. You can't just assume that because second derivative equals naught that it is going to be that. And of course with the sketch, what are we looking for with the sketch? Well, you're asked to show a few points. You're asked to show stationary points, you're asked to show point of inflection, and you're asked to show the y-intercept. So we're looking for those things. We're not looking for the x-intercept because we weren't asked for it. Please make sure your scale on the x-axis is consistent. Now, we had it where it cuts the x-axis, we had a third, and we had another value. You've got to make sure your x-axis is consistent. Your y-axis does not have to match your x-axis. But if you've got some points on the y-axis, say a value of 1, and then another value of 10, then another value of 37, then your distance you go from y equals 0 to y equals 10 should be about a quarter of the distance from y equals 0 to 37. They've got to be consistent. And if you think you're running out of space, well, obviously your diagram's not big enough. So give yourself plenty of room, that half a page again, so you've got plenty of room to put the points. Label your points. I don't mind if you actually write the coordinates on the points or whether you use the values on the x-axis or the y-axis, but there's got to be a label there that the marker can see where they match up, what you have used for it. You're going to get a superannuation or a time payments question. Right? You're going to have one in there. You might be lucky and you might have two of them. They might combine them together as they have done in previous years. These questions are normally structured to give you, the candidate, some guidance along the way. This is what you're aiming for. It's very rare just to go told to work out the answer. But because it's going to be a show that, don't work backwards. You don't start with what you're supposed to show and then work back to where the beginning was. You're supposed to start at the beginning and work forwards up to that point. Now in 2-unit mathematics, candidates are expected to be able to develop a solution. In General 2, they are given a formula they can substitute into, but you're not. So you cannot just memorise the formula to use in this. You've got to develop a solution. And what I mean is you've got to work it out for the very first time period. And then substitute in for the second period and develop your pattern. And you want to develop your pattern for at least 3 time periods. Now every textbook does this, so it should be very obvious for you how we develop the pattern. And I only go for 3. From the third one, you can then usually jump to the last one, unless the question has broken it up for you already and say, show this is your first, this is your second, and then go to the last one. In superannuation, annuities, time payments, loan repayments questions, they always use a sum of a geometric series. We look for it. Now the sum of a geometric series is a formula that is on your reference sheet. So you've got that there to look to refer back to, but it's going to be in there. As a marker, we look for it. So you've got to make sure that you work a geometric series in. And if you're going to work a geometric series in, make a little note on the side of it, what you've used for A, what you've used for R, and what you've used for N. Once again, you're making it easier for the marker to say, oh, this is what the values they have used. Because it's very hard sometimes to try and work out exactly what students have done, especially if they skip working. So don't skip working, put your little values there. I talk about a shopping list, a little shopping list of the values I'm going to use for my substitution. It makes it easier for us. Sometimes with your series, you get a series and you think, oh, that looks a bit strange. Now there's no problem about rewriting the series out in the form that makes it easier for you. I've got up there, remember, 5 plus 4 plus 3 happens to be equal to 3 plus 4 plus 5. So there's no problem in rewriting your series into a form that makes it easier for you, to especially to find A and to find R. These questions are nearly always worth 3 marks. And the first mark is always pretty easy to get. It can be something as simple as converting the interest rate from per annum to per month. It can be as easy as knowing that if it is a loan repayments question, at the end of the time frame, you're going to repay the loan, so it's equals 0. They try and set it up so the first mark is very easy to get. And if you've developed a solution, we can look back through it. Even if we're going looking at a previous part, we can do that. We can award you marks for part 3 from some working in part 2, if the working in part 2 is applicable to part 3. So develop your solution and show it. And I know you're going to get one. It's going to be in there somewhere. Geometry. Basically, for the last few years, geometry has been either a congruent triangles or a similar triangles question. And I think you'll find that it's mostly been similar triangles for the last few years. Always draw a diagram first and explain any extra points or lines you've added. You can put them in. No big deal. You can put them in to make your explanation easier, but explain them as part of your working. Abbreviations. Abbreviations is probably one of the biggest bugbears we have. Do not abbreviate, avoid abbreviations. In actual fact, there's probably only one abbreviation I would use, and that is the triangle symbol for the triangle, which I think you might see in a minute come up. For everything else, write in words. This is your one chance to convince a couple of people that you have never met before, that you will never meet, that you know what you're doing. So don't abbreviate. Write the full word. If you've got the word alternate, write alternate. Don't abbreviate it down. Each step or fact needs a geometric reason. All right, so if you are saying for some reason that angle ABC is equal to angle XYZ, then you've got to give a reason for it. Now, if your question has multiple triangles or it has parallel lines, you've got to state which triangle or which pair of parallel lines you're using. So you can't just say those two angles are equal, alternate angles, parallel lines, when I don't know whether you're using AB and CD, or AB and DE, or CD and FG or somewhere else. Angle sums of triangle. Once again, if there's multiple triangles, state the triangle you are using. It makes it easy for the marker to be able to come back and say, right, I know where they're heading, I know what they're doing. It makes it easy for us to allocate the marks. The other thing with abbreviations is, of course, you might have been using for the last 2, 3, 4 years. You will know exactly what they are. Your teacher, who you might have had for 2 years, might know what they are as well. But they're not the people marking your HSC exam. And you've got to convince them that you know what you're doing. So you might have some strange abbreviation that you've got used to using, VOA for example. Oh, what's VOA? Some people might say, oh, that's vertically opposite angles. Yeah, but you can't assume that the person marking knows that or has used that. So you've got to be very careful with abbreviations. I cannot stress that enough. Similar triangle tests need to be written in words. You cannot shorten them down to SSS, SAS, AAA, etc. If you're talking about 3 pairs of sides in the same ratio, you need to write 3 pairs of sides in the same ratio. You cannot abbreviate it. Now, similar triangles, I think they've used similar triangles tests every year since about 2010 or 2009. Similar triangle questions in the HSCs normally involve angles in their testings. You'll see equiangular as the most common sort of reason for similar triangle test. The reason it's the most common is that they can then go and use the sides as part of the follow-up questions. You know, you'll explain usually in part 2 of it that the matching pairs of sides are in the same ratio, and then that will lead into a further question. In 2015, it was question 15 part B. In 2014, it was 15 part B. In 2013, it was 16 part C. In 2012, it was 16 part A. They're all good examples of questions where you firstly prove a pair of triangles are similar, equiangular, and then in the second part of that question, we use the sides are in the same ratio and then go on and prove something else. And once again, please write your geometric reasons in full words. You're going to get a max-min question, and this is the last of things. So when you read the question, go looking for the words maximum, greatest, or minimum. And once again, it should trigger a response. You should then think, right, I'm going to differentiate once, twice if you think it's an easy one to differentiate. I'm going to let the first derivative equal naught and solve. I'm going to use my first or second derivative test to show it's a max or a min. And make sure you answer the question. Now that might seem like a strange thing to say, but people will go through their working, they will do everything they're supposed to do, they'll finish up with x, a value for x, but they won't actually answer the question that's been asked. So make sure you read the question carefully. So if the question at the end actually says something like, so what was the shortest distance between the two people? Or what was the minimum volume? Then make sure you answer the question asked. Max-min questions usually include at least one show that, where you need to develop a formula or an equation. We do this so that students can get into the question. They're probably going to be worth 5, maybe up to 7 marks, and we don't want to cut them out if they can't do the very first bit. So we give them a nice show that to introduce them. But remember, if you're doing a show that question, you don't start at the answer and then work backwards. What you are showing is what you are supposed to finish at, and your working is supposed to work to that, so that the marker could cover it up and say, yep, that person knows what they are doing. Now, you've got your reference sheet, but what happens if they want you to use a formula that's not on the reference sheet and it's something from year 10? It might be from the 5.2 course or the 5.3 course. In those cases, they will give you the formula if you need it. For example, they will give you the surface area of a cone, or they will give you the volume of a sphere. If they want you to work with those formulas, they will give them to you as part of the question rather than cluttering up the reference sheet. In 2013, question 14, we had an example of a max-min question where we had 2 people driving cars, one starting from a point 100 kilometres away, the other one starting at R and moving. And part 1 of the question says, show this result. R squared equals that expression. Show that result. Part 2, find the minimum distance between the cars. So I see the word minimum and I'm automatically thinking of those steps before. Differentiate, equal to naught, sub in to show it's a minimum. I ran through this one very quickly because it was an interesting little take on this. Let t be the time travelled, and we then write down what we expect our 2 distances would be. Most people would realise it's not a right angle triangle, but I'm finding a length in a triangle, so it's probably going to be a cosine rule. So I've substituted into my cosine rule, and because I am showing it, I am going to include extra working steps along the way. So I've expanded some brackets. I've changed cos 60 to a half. I've then simplified it down to the required result. R squared equals 12,900 t squared, etc. So I've shown the result I'm after, and I've then asked for the minimum distance. So we need to find R. Now with these questions, R wasn't the subject. R squared was the subject from part 1. Now obviously I'm supposed to use that, but there are 2 ways you can do it. And like most things, there is a hard way and there is an easy way. The hard way would be to make R the subject and make it the square root, but don't do that. Take as a little trick. You can make R squared equal to some other pronumeral. I've just used S as an example. Differentiate in terms of S, which made it a very easy derivative. This was just 12,900 times 2t minus 1800. It made a very simple second derivative, which was 25,800. Oh, that's greater than naught. Therefore, it's a minimum. So I've already ticked off the minimum part of the question. First derivative equals naught. It's a simple solve. Now, don't be afraid of leaving your answer as a fraction. Don't reach for your calculator and try and make it a decimal. Leave it in fraction form, because remember, as markers, we will pay you your answer in fraction form. For this question here, I've got R equals, and I've done the square root because it was the minimum distance I was after. But as a marker, I would pay it at the square root of brackets 12,900 times 30 over 43 squared minus etc, etc. I don't worry about the 60.99 or the 61. I assume that if you can substitute into that formula then you can use your calculator to work it out. So that's, as a marker, that's where I would pay it, and as a senior marker, that's where I would want my senior markers to pay it. 2014, I think they had there were pies and other things in there. Don't get confused about it. Don't worry about that, right? We know what we want to see. Use the fraction form. Don't decimalise it. So you're looking to prepare for the HSC. Go back through your past HSC exams. Go to the Board of Studies site. Look at the marking guidelines. Look at the examiner's comments. Go over them. Make sure you do them. Do as many as you can do. If you walk into an HSC exam and you haven't done at least 15 HSC exams, then you're not fair dinkum in your preparation. If you haven't done heaps and heaps of trial papers from other schools, and don't do them all at once, just slowly work your way through them. You should be even starting now. Look at the topics that you have done. Ignore the rest, but look at the topics you have done. Remember, you don't want to be surprised. So that the more questions you can do from the more sources, the more chances you will see all the variations on the questions. The Maths Association of New South Wales runs HSC lectures in July every year in Sydney, where they have people come along and they kind of do a summary of the course, plus they look at possible ways questions can be set up. Normally it's about 2 days for 2 units. They do a basic one on the first day and a beyond basic on the second day. They are worth going to get someone else's perspective as well. Probably one of the biggest dangers is you've got used to listening to your teacher talk, and your teacher talks the same way, explains the same way, asks questions the same way. Go and listen to how someone else explains various topics and see what you can pick up on. In Newcastle here, we have a HSC review day in September, where we've last couple of years we've gone through the 2-unit paper and we have gone through the General 2 paper. Come and get their perspective of what went well in the HSC exam, what students did well, what students did not do well. Keep your eyes open on the Newcastle cluster part of the Maths Association of New South Wales. And do questions, and do questions and questions and questions. That's the best preparation that you can do. Get a good night's sleep beforehand, and all the best with your HSC exam.